Assalamualaikum warahmatullahi wabarakatuh. Greetings, my name is Patrick Ray Samperuru from the International Class of Mechanical Engineering, batch 2021. In this video, I will be presenting my final results of the simulation in OpenModelica for the steam turbine power plant simulation for the energy conversion system 2 class. The part that I got is mainly the boiler as well as the pump of the turbine of the power plant. Right, so I'll be briefly explaining my project of the boiler first. So here we have a total of 1, 2, 3, 4, 5, 6, 7, and 8 different components. And that consists of, first of all, here, the water steam source, and then we have the flue gases source, and then we have the source of fuel. Here we have the boiler itself, along with two singular pressure loss components, and then finally we have the sink, and here we have the flue gases sink. So in this entirety of the boiler, there are several inputs, starting from the fossil fuel boiler. So the fossil fuel boiler has an input of flue gases temperature at the outlet in degrees Celsius, the flue gases pressure loss coefficient. In fact, I'll just open it here. So we have it here. Flue gases, water steam pressure loss coefficient, as well as thermal losses and boiler efficiency, which I put at 0. And this will influence the value of the specific fluid enthalpy crossing the boundary of the boiler towards the turbine in the next component. We also have two singular pressure losses, these and this. So these two singular pressure losses are responsible for the pressure loss coefficient as given from Thermosys Pro, and this will affect the fluid pressure output as well as potentially even the specific fluid enthalpy as well. And then next we have the fuel source with a fixed pressure and a fixed mass flow rate. The inputs include the mass flow rate in kilograms per second, the fuel temperature in degrees Celsius, the LHV, lower heating value, as well as fuel-specific heat capacity, which influences the specific fluid enthalpy, again, that is exiting the boiler. Next is the water source. Here the inputs are the fluid pressure, mass flow, as well as the fluid specific enthalpy, and this will influence the values of the specific fluid enthalpy output, again, the mass flow of fluid crossing the controlled volume, the fluid temperature, as well as fluid pressure that is, again, crossing the boundary conditions from the boiler. And then finally, we also have the flue gases source input with a fixed mass flow rate. The main components that are influenced are these that are changed in the parameters are the source temperature as well as the mass fractions of the air. And this will result in the output of the fluid temperature, fluid specific enthalpy, and mass fractions of the fluid. And then finally, here we have the two sinks. And so let me move this down here. If I simulate, it's taking time. Okay, so if I simulate, we obtain these, and mostly what we will see is the sinks, because obviously that is the output, specifically here. So we have the new fluid pressure at 110 bars, the mass flow rate and enthalpy is the same, but here, the specific enthalpy of fluid crossing the boundary of the control volume, we have in ideal conditions, then it will be around 3.13 times 10 to the power of 6 joules per kilogram. Again, and with the fluid pressure of as so. And then we also have the fluid temperature. We have the mass flow and so forth. So this is overall how the boiler is modeled and how it can be simulated and change the inputs according to the laboratory input. Now, unfortunately, this is where as much as I can do, because so we see here at the simulation, so it says that the equation there are 462 equations and 462 variables. So theoretically, it should be able to be simulated. However, unfortunately, for whatever reasons that I could not find, the simulation will show a failure message down below, as so. So yeah, simulation process failed, exited with code, as so. And I've really looked for solutions. I've tried changing the parameters. I've tried changing the source here, especially the source here that gets inputted into the water turbine or steam turbine rather. I've checked the programming, I've checked forums online, and I could not find a solution until now. So for our group project later, what I proposed was to at least be able to simulate our own items, as this can be simulated by itself, and then this can be simulated by itself as well. So what I proposed was that we would simulate our own parts together, but here later, the input in this source will later be based on the output of this boiler, basically. And that's basically how it is. And then obviously this is still missing a pump. So if we go here, I've also made the layout with a centrifugal pump here for the water that is already cooled by the condenser or condensed by the condenser to go back into the input here for water. And unfortunately, again, the results show that there are too many equations for the variables that are available. Again, I have not found the solution. I've really tried every single step that I could. I've checked the programmings. I've checked the programming codes. I tried to check forums online. I tried to ask some of my friends who were working on similar applications like this, and no solution was found. So unfortunately, we are not able to simulate this per se. However, using Thermosys Pro, I believe there is a example from the book for a centrifugal pump that perhaps could give a better imaging of how it is overall. But so here, yes, that is my boiler project with the plotted outputs as follows. And yeah, that wraps up basically my project. For a little reflection, I believe that I was able to get this far with my consciousness and by using the implementation of the conscious thinking method of DAI-5, starting with intention, followed by initial thinking, idealization, as well as instructional set. However, I was unfortunate that I could not be able to solve several problems that were present. However, we did find alternatives, as mentioned previously, to simulate our own parts together. However, the inputs are based on the simulation of the previous parts. And yeah, I believe that is it. Thank you for your time and attention, and stay conscious. Assalamualaikum warahmatullahi wabarakatuh.